Hello, everybody. This is Thomas Beebe with Advanced Data Tools. Welcome to our next installment in our ongoing online webcast about Informix. Today is April 11th, or it is whenever you happen to be watching this on YouTube. Today, we're going to be talking about Informix encryption, going through a basic setup to enable client server SSL level encryption. Okay. So a little bit about the webcast. We are being recorded. So a couple of days after this goes out, we're going to have it then post up on YouTube, and it will be up on our website. If you happen to have a microphone, please mute it or make sure you stay muted. We don't want background noise coming in. If you have questions during, use the chat button. I'll answer a few questions during. Mostly we'll have a Q&A at the end. As always, thank you for being on. So what we're going to talk about today, we're going to talk about encryption. Some of this, maybe you may have been working in encryption for years. We have some people that are on that have never worked with it before other than as an end user. We're going to talk a little bit about what it is. We're going to go through how to configure it with Informix, how to set up both the client and server side, what we need to consider, and then basically just do a walkthrough of why do you need it, how do you set it up, and then how do you keep it running. So what is encryption? This is a very, very high level overview, but it's effectively encapsulating your data from one point to another with some kind of shared secret between you and the person receiving it, so that your data is protected from prying eyes. Obviously there's tons of old analog versions of this. World War II, the Enigma machine would be a real good example of that, to, the modern ongoing race for stronger, better, faster encryption methods. The key thing with all of it is the intention is to keep your data secure between you and the person or target you are giving your data to. And that's exactly what we're going to be doing with this with Informix. The big thing to keep in mind with computer-based encryption is it uses CPU. Every single bit of data that is being encrypted, it needs to go through a series of mathematical formulas to whatever mechanism you're using to take your data in your nice plain text, easily readable, and put it in a way that is secure, but it can also then be decrypted on the other end. Both sides of that equation need to have extra CPU running, because it's going to have to do all of that extra math on every little packet of data or every little container of data to encrypt and then decrypt. So you need to keep that in mind. But that's how, on a very high level, that's what it's doing. All of encryption can be configured for, all of the encryption we're working with, I should say, can be configured for desired strength versus security, or versus speed. And we'll talk a little bit about tuning with that. So public key infrastructure, you may have heard the term before, PKI. You use it every single day because HTTPS, or standards for web encryption, is all based on it. The basic concept is you have a two-part encryption mechanism. You have your private key, which is unique to the server. The server itself has a key that is issued by a third party that says this is who it is and this is how I decrypt my data. The second part is a public key. That public key they give out to everybody effectively for the website, for web servers. You go to Google, you go to HTTPS on Google, you've now got a copy of Google's public key. And how it works is you'll actually send the data encrypting using the public key to the server on with the private key, and it'll validate the whole process. I'll talk a little bit more in a moment on that. The other term that we're going to be using is certificate authority. So this is the third party that actually issues the keys. This is a trusted host that says you are who you say are. When you go to pick your website of choice, CNN, Fox News, whatever your news channel of interest is, you're going to the server that is who they say they are. So you're giving them the keys for that server to connect to. So it's both issuing the certificates and also validating them. In our case, we are going to be using an example of self-signing. So we're going to act as both the private server as well as the certificate authority in one. There are other options out there, but I'm keeping this a little simple for getting going with this today. So how Informix actually uses private key infrastructure, to actually talk about a little bit on the nuts and bolts, is it goes through pretty much a 5-step process. First step is a user comes in and will get a digital certificate from the client, from the server. Then the client will actually validate the digital certificate. If it's self-signed, you have to kind of manage it yourself. If you're dealing with a third party, that third party would be the one to validate. The client then creates a limited use key, encrypts it using that public key it got from the server, and sends it over to the server. The server gets the key, decrypts it, and then for the rest of the time that they're communicating, for whatever the length of time it may be, different utilities have different lengths that a key will be valid, they'll use that effectively one-time key. So they're not decrypting using their public key, private key. That is just for the initial handshake to make sure everyone who is who they say they are, we know what encryption mechanisms we're using, etc. What it actually does is the client will actually furnish a single use key that'll actually be used to send all the data across. So even if somebody else who may be a bad actor, let's say, gets a copy of the public key, that knows how to communicate with the server, it still doesn't know what other users are doing and what they're saying. It doesn't have that person doesn't have access to any of the other data going across. So everything remains very, very secure, because there's no way to decrypt somebody else's information without that single use key, which is then useless and discarded when it's done. The parts that we actually have to manage from an administrative standpoint are the public and the private key, steps 1, 2, and 3. Those are the parts that we as people actually managing this process need to deal with. 4 and 5 are entirely during the transaction themselves. We never actually see it happening. We just know it happens under the covers. That's all for the gurus in the Informix security division to deal with. So why is it actually important? Why are we having this talk? One of the biggest things that has been coming up over the last, probably really 5 years, but really more than that, 10 years, is regulations coming in and impacting private industry and obviously government as well. Regulations on security, regulations on protocols, etc. There's a lot of things that governments are stepping in. The EU's passed a whole lot of laws on this. The US government has plenty of their own, as do most of the other governments around the world, for how data is protected, how companies are supposed to operate with this. And on top of that, we have auditors, we have independent industry analysts, plus your own, chief security officer and whoever else who is probably setting in their own policies that the company needs to follow. Almost all of them, require data is protected, data is secured. And the reason being is it's relatively trivially easy to sit and listen to somebody else's traffic. There's a million different ways over the years that people have tapped into corporate lines, but as soon as you've got a tap there, whatever data is going in what we call clear text, stuff that is not encrypted, stuff that is just plain text going across the wire, somebody theoretically could see it. And that's where encryption comes into play. Even if you're only running internal to your own office, if the data is unencrypted, if somebody is able to listen into the wire, they're able to see what you're doing. The biggest one for a lot of security people with Informix is by default, your passwords are sent in plain text. You log into an Informix server, your login and password is sent in plain text. That is a big security red flag for a lot of auditors. Be aware of it. So what does encryption buy you? It means that that's not sent in plain text. It also, using encryption, you'll verify the server you connect to is the one you're expecting to connect to. If somebody puts something, a fake server in place to try to get data you're not expecting from them, for whatever reason, an impersonator effectively for the server, the using SSL will actually help give you protection against that, because it'll actually do that validation at the beginning to make sure that the public and private keys match. And if that fake server doesn't have the correct private key, it's not going to match and it's going to fail, and you know that something's wrong. Another big security vector that it helps with is what are called man-in-the-middle attacks. This is where somebody will put up a piece of code between you and your server and change the packets on the fly. Maybe you're inserting bank records and, it's changing your deposits to, that person's, account number, any number of things that they could be doing. When you have all the data encrypted, you can't have somebody in there sitting in between changing things up. Obviously as I said, it lets you avoid a third party, watching your data. Regulations, there's many of them out there. Lots of them require this. Do note also, you may want to, if you're looking at implementing this in your organization, you may still want to consult with your security team to find out what kind of regulations they have in terms of what levels of encryption, how strong keys have to be, etc., because that is a consideration. And the other big thing is there are other ways to encrypt data rather than doing it on the software level, but with doing it for Informix, it means that the end-to-end from my client application to the database server, every single bit of data going across that wire is encrypted. Some of the other techniques, and we'll mention that at the end, will encrypt it most of the way and most of the sensitive ways, but there'll still be a little part there that is not encrypted. So just to hammer home my point of where encryption matters, I pulled this yesterday, so I promise there's nothing faked here. A little demo system between a Windows box and then a Linux Informix server, and just tossed on Wireshark on the Windows system, which is a packet sniffer. It's looking at the data going across the wire. And what I did is I pulled 3 screenshots here. These are actual packets going across. And what you see down here in all the hex code in the middle of it, right as the blue text starts, you'll see SQL exec, Bob, which is the username I was using, -p, and ifx pass, which is the password. This right here is the login and password I use to connect. Then it goes into all of the SQL or all of the information in my environment, etc. But I've just given an attacker my login. That's, especially if you're using shared logins with the Unix system, we've now just had a major security incident. Again, if everything is internal, your entire network's totally locked down, may not be quite as important, but you never know how locked down it really is. The second packet capture here is I just ran a simple select statement. You see at the very end of the text at the bottom there, select star from items. I was going against the store's demo database, so there's nothing really sensitive here from what I'm doing, but I, as a third-party, viewer, I am now actually sniffing what SQL is going across. And then finally, and this is a little ugly to read, but obviously someone, who's determined could put it back together, I pulled a packet from, this is the data being returned from the server. So you can actually see where it actually has some of the address data from the orders table, actually, in this case, returned back. So this is actually the data being returned back. So this could be sensitive data, this could be your private data, this could be whatever is in your database that somebody is pulling back. A third party now could be watching it. So obviously we want to prevent against this. So a few considerations before we get going. Number one is I would talk to your security team, make sure that you know what regulations you have to follow. The last thing you want to do is implement this great security, SSL environment, and then find out that you did something that doesn't, work with their requirements. You're going to need setup on both your server and any clients you want to access over SSL. I will also mention that for Informix, your SSL listener is a separate listener from your normal TCP connection. So you can roll this out incrementally, where you add in your SSL listener as a new listener, and then slowly convert over your clients. If you have, one client where it's your application server and then your database server, great, really easy. But I've been to plenty of clients and I have plenty of customers who they've got, 8,000 different client desktops that all connect directly to the Informix server. Those environments, it's going to take a while to roll out the changes, roll out the SSL, and so you can do it incrementally. You don't have to go all in at once when you're actually rolling this out. And I mention this because I want people to use encryption. I don't want you to feel that, oh no, this is too big of a job. We can't do it. It's going to impact too many people at once. You can set it up and then roll out a handful of people at a time, or roll out to some of your critical systems first, and then move to some of your other clients, ODBC connections, what have you, as you go down, with new software patches or however you do, upgrades. So don't feel you have to. So other considerations when you're planning this out, you're going to have additional CPU overhead on both sides of the connection. This can be a problem if you're dealing with older hardware. I recently benchmarked this for a client. They had 2 sets of hardware, one of which was about 6-year-old HPUX titanium boxes. When I did the benchmarking, it added about 35 to 40% overhead. We're pulling back about 500 megs of data for the benchmark on this, and it was adding about 40% extra time to do it, because it was having to then encrypt on each part and then decrypt on another part, or when it was returning the data. So it was a lot of extra CPU that was happening every single time. And those older titanium chips are just not that fast for that kind of work. That said, I then took their newer Linux systems, these were Linux, Intel. These were not massive state-of-the-art systems. These were just, fairly mid-range Linux servers, ran the exact same benchmark. It was 4 to 5% CPU overhead. For all practical purposes, they noticed no difference with implementing. So if you're working on really older hardware, this is something to consider. Another limit is this is really meant for CSDKs that are version 3 or later, which corresponds with Informix 11 or later. Hopefully nobody is still running CSDKs in the 2 versions. I know there people are. I personally know some people that are still having to because of legacy applications. Be aware that this will not be supported on anything with CSDK prior to version 3. So you will have to give other considerations if that's the case. Also, if you're running legacy like ODBC connections, those will not work. Most everything else and most anything that's been written in the last probably 10 to 15 years, it should be fine for, but I wanted to bring those up as a couple of sticking points. The other one to look for is if you're running third-party drivers or anything that's just something really old and strange, you're going to have to test to see if it works. I've got a list here in a moment on what it is supported. Next consideration is certificates expire. Part of the process we step through here in a few. We're actually going to give it a lifetime for the certificate. So this is the public-private key pair. Default's about a year. You may have reasons you can have up to 20 years in length. You may have reasons for longer, smaller. You really need to talk to your security team to see if they have a particular requirement there. The other consideration is how big is your key? This is how many bytes effectively of data you're using to encrypt it. Default used to be 512, then it was 1024. Now 2048 is about the standard, but a lot of places are now moving to 4K effectively in size. The larger the key size, the more secure, the harder it is to break that encryption. But the larger it is, it means the more CPU that is needed to actually encrypt each packet. So if you're running some really fantastic new hardware, have a big key, you won't notice the difference. But if you're running something and you're just kind of struggling to get by, you may need to find a compromise. I wouldn't say go anything smaller than 2K if you can avoid it, but there may be reasons for it. So what actually is supported for Informix SSL? So we enable Informix SSL on the server. What can I use with it? ODBC, JDBC, and SQLJ connections work out of the box. There's a number of tutorials out there that the IBM's put out for configuring JDBC in a couple of different ways. This topic, I'm mostly going to be covering ODBC setup. It supports DRDA and SQLI or SQLI. If you're working with DB2, the DB2 implementation is very similar. They actually use the same base toolkit. ESQLC supports it, DB Access, your ER connections will support it, your HDR connections will support it, so you can set up your replicates to go over SSL-based encryption. Your standard utilities, your DB unload, your DB export, all of those you can connect up over SSL. Connection Manager supports SSL, so if you're using that, you can definitely enable SSL with it. If you're doing distributed queries, they work with it. And if you're using single sign-on with PAM, that actually has its own module that you can actually set up to use it as well. I have not used it personally. I just found it in the documentation. So the tool that all of this runs on, or is all configured on, is the IBM GSKit, the Global Security Kit. This is shared between a lot of different IBM utilities, WebSphere, DB2, Informix. There's a number of other pieces that all use it. It's a set of utilities to actually get and manage certificates, keys for different purposes. The certificates are actually the same between different products, so you can actually set up different pieces the same way. There's a ton of different options. There's a huge PDF they put out for how to use this. I'm very much focusing this talk on a very limited subset to get you up and going with Informix, but there is far more there. If you have particular security needs, you can talk to your security team to figure out which flags you're going to need to use with the tools to get it up and running. So it ships with the CSDK and with the server, with the CSDK part of the server. It's free. You can get it standalone as well. So it's going to give you a bunch of libraries and utilities for SSL and TLS communication. TLS is another overarching encryption type. One thing I will mention with the GSKit, if you're running an old version of Informix, specifically an earlier version of 11.5 prior to FC7 or 11.7 prior to FC7 or 11.5 prior to FC8, there were a number of security holes because GSKit's based on OpenSSL. Just check your version, check the Google Informix Informix SSL. It'll give you several releases that came out in early 2017. Just make sure you're patched is all I'm saying. Just because there was a small hole that came out was not IBM or Informix's fault. This was based on the open source OpenSSL library. I'm sure any of you that worked with system administration spent plenty of time patching everything that ran on OpenSSL at that point. So again, if you're running an out-of-date version of Informix, just make sure your GSKit is patched. You can actually get a separate GSKit to manage that. You don't have to upgrade the whole server. I just wanted to make a note of that. So the primary utility, and the one we're going to be using a whole bunch today, is GSK8 CAPI-CMD. A little bit of a mouthful. I'm just going to call it GSK8 when I'm talking here a fair amount. If you're running a Informix version 11.5 or 11.1, that was shipped with GSKit 7, so it's GSK7 CAPI-CMD. Works pretty much the same way. If you want to dig through the docs, you can find the differences. But for our purposes, the flag should be the same. The usage should be the same. So if you're running that, just make a mental note to change the 8 to a 7. So a little bit of terminology before we get started. We're going to talk about key stores. These are a small file-based database of certificates. So this is public and/or private keys that you actually have in a small, tiny little database file on your system. Then you have your stash file, which goes along with it. This is a local file that actually has passwords for your key store, so that things like Informix can actually retrieve that data from a passworded key store without having to prompt you for the password. Because the last thing you want is if you're doing nightly maintenance, or Informix, your system restarts, for Informix to hang waiting for somebody to enter a password. So what it will use is the stash file, which is a very strong protected file, to pull the password it needs to pull the key store to basically pull your private keys to get Informix up and running. The last terminology we're going to be using is the certificate, which is basically just a flat file or a standard file that actually holds your public key information. So we're actually going to go through the steps to actually create a certificate based on our public-private key pair. So the steps we're going to follow here is we're going to configure our server. We're going to add our SSL listener to our SQL hosts. We're going to create the key store. We're going to create the server certificate. We're going to create a file called conssl. I'll talk about in a few. We're going to create the client key store. We're going to pull out the certificate from the server, and then we're going to add that certificate to the client key store. At that point, step 9, we test it. At that point, we are up and running with encryption. Honestly, when it comes down to this, getting a server up and running with encryption, it will be 5 commands. So we talk a lot about different possibilities. We talked a lot about why we want to do this. The reality is the actual implementation is pretty easy for once you've decided everything you want about it. So configuring the server. First thing, we want to verify GSKit is installed. There are certain older versions may not have GSKit installed. You might need to install the client SDK separately. Just find out if your GSK8 command is there. Some environments it's installed in like /op/IBM/GSKit. Other ones, and I found most of the 12.1 editions actually install it during the server install into like user bin or just /bin. So it may already be in your environment, but find out if it's installed. Second part is we have a couple of onconfig parameters to adjust. We update our SQL hosts, then we create our key store and then bring it online. So our onconfig changes, what do we actually need to set? The first one, and this is really critical, so give this some thought, is our SSL key store label. By default, it's blank. To set this up, we need to use it. What this is going to be is what we're effectively using as our label for the server. So when the server comes online, this is the label it's going to look for in our key store to make sure it's using the correct private key. You can have more than one private key in a key store. Think of it as a little database. And so Informix needs to know which one is it going to work with. The second piece we're going to add is a net type. Sure, most of you have worked with this, adding net type for like SOC TCP, for example, or maybe tuning up the shared memory one. In this case, we're going to add a new net type for SOC SSL. So just like with the SOC TCP, we configure this based around the assumed number of network connections. 150 is sort of the real base. I'm running a tiny server. Obviously, configure this depending on your needs. Next one is the VP class encrypt. So we're going to add a new VP of type encrypt. Default, you just need one. If you're dealing with a big server, obviously you need more, but this is actually the VP that'll go in and actually deal with the encryption itself. If you do not have this in your onconfig, it'll spin one up for you automatically, but it's good to have it in there so you can control it. And the last one is we're going to add a new DB server alias for our SL listener. So in our example here, we're going to take our existing connections where we've got a shared memory and a TCP connection and add a third listener for SSL. Obviously, you could take your TCP connection and change it to an SSL if you want to. Certainly, there are reasons to do that. Most environments like to do a rollout, so you'll often add the third one as SSL, and then maybe you turn off the TCP somewhere down the road. So, updating SQL hosts is pretty straightforward. Just like with other SQL host entries, we give it our listener name, which is IFX server SSL. We're going to use that name throughout. The second part, this is where it's a little different. Rather than on SOC TCP, we're going to give it on SOC SSL. And then we give it server and port. Obviously, the port needs to be different from any of the other listeners on the box. So now at this point, we have set up our onconfig, we set up our SQL host. Next thing we need to do is actually create our key store. So this is going to be creating where we will have our private key live. We're going to run everything in Informix dir/SSL, which on modern versions of Informix should already be created. If you're dealing with the legacy version, you may need to go create that directory manually. Just a reminder here again, if you're running these commands, if it's legacy, you may have GSK7. The other note is if you are on a 64-bit system, and specifically that you're on a 64-bit system running 64-bit client SDK or 64-bit server, the command is actually going to have an _64 on it. It works exactly the same. It's just making sure that you're running it the correct 32 verse 64-bit version. For example, our DB server name is IFX server. I've got really, special and unique on this one. And the keystore label here, we're going to call it IFX_encrypt. So anywhere you see IFX_encrypt, that is our label. And the other note here, and this one has tripped me up a few times because I'm not thinking about it. Your DB server name must match the keystore and stash file name. So we're going to give the file names here in a few, but we need to make sure it matches the DB server name, not the DB server alias's name, but it needs to be the proper DB server name. So just keep that in mind if you're scripting this out, if you're deploying this to multiple systems, you need to have the end files actually be named the same as the DB server name. That's how Informix knows to look for this file. It is by the DB server name in the SSL directory when it's actually looking at what encryption or keystore files to open up. So to actually create the keystore, and these commands are a little ugly, and I kind of break them down for every flag we're going to use here. There's way more flags that we're not using. I'm not documenting all of them. So GSK8 CAPIC MD_64. That's the whole command. Then we're going to be at -keydb, which tells it to actually use the that's the section of the command we're going to use, and we're going to tell it to create a new one. And then the -db is actually the file that we're going to be writing to. So IFX_server. So note again that our DB server name for the system is IFX_server. So we're calling the database IFX_server.kdb. Next thing is -pw and then a password. So this is a unique password for actually storing this private public key environment. Obviously, it depends on your environment, how secure you want to make this password. I recommend making something fairly strong. It's not really going to matter because we're not going to use it a whole lot after this. If you have different environments or different security requirements, you may have to have a stronger password for this and do more with it. The next thing we're doing is type CMS, which is we're telling you just we're using certificate type. There's a series of different keystore types you can give it. CMS is the one recommended for Informix. It actually, the GSKit supports 4 different types. Some of them have different particular purposes and for different environments. There may be security reasons why you need to use a different one. I have never used anything but CMS with Informix. And the last thing we're going to give is stash. What this actually does, will stash take our passwords that we're using here, the -pw, and we're calling it just using password here, but we're actually going to stash it in the stash file. So utilities that are trying to access this data don't have to have a human intervention to manually input the password. It's able to pull that password from the stash file. So at this point, we run this, we've got our key store created. Second step is we need a certificate, a server certificate. This is the public-private key pair for our Informix server. So again, we use the GSK8 CAPIC MD 64 utility. In this case, rather than using keydb, it's going to use -cert. So we're telling it to work with certificates, and we're going to create, and we're going to get the DB of the IFX server. So it's going to use that database file we created for IFXserver.kdb, and we're going to tell it stashed. So it tells it to actually use the stash password, so we don't need to pass that. And here's where we get the label. So the label, the IFX encrypt. Though again, this label matches the label we gave in the onconfig. So when Informix comes up, it's going to know to look for that label in that key database when it's actually pulling which certificate to use. The next one is the size. So again, this is 2K. Plenty of places are using 4K these days. Check with your check with your security folks for what your requirements are with it. The next one is default cert. So if you're dealing with multiple certificates in a key store, you probably want to make sure one of them is the default. The default is only used if you don't have a label defined in the onconfig. So if you've forgotten to do that, it'll pull whatever the default certificate is. I generally recommend always having it defined. It just makes life a lot easier if you're not having to guess. Next one is expires. So this is, I'm actually going to jump to the next slide here because I spell everything out on those. So expire. This is the number of the days for the certificate to be valid. Defaults 365, 1 year. When that certificate expires, the public-private key pair is no longer going to work. If you tried to bring Informix back online with an expired key, it is not going to come up. You're going to get an error thrown. So keep that in mind that if you do a expiration period, you're going to have to every so often, if you do 365 days, maybe every 9 months, you go out and issue new certificates, in which case you're also going to need to go through and update your clients with new certs. If you're in an environment that can get away with it for a longer expiration date, by all means. The reason for an expiration date is twofold, one of which is encryption policies and recommendations change constantly. About every 2 or 3 years, security teams will come out with new recommendations for how strong and what type of keys to use. So you don't want something where you've set a 10-year certificate and 5 years in, some security guy has found that there's a way to defeat the level of security you're using, and suddenly your SSL implementation is not supported or not really secured. So computers are getting faster. People are finding very creative ways to defeat things. So it is a bit of an arms race. So if you have a really long expiration time, you may have problems where things either aren't supported down the road or it's just simply you're not as secure as you really think you should be. In an environment where you actually have a separate certificate authority issuing all of your certificates, you can actually do more to control this. The other thing that can happen is if a certificate is compromised. Let's say your server gets broken into, somebody's able to pull your stash in your private key file. You can revoke a certificate and basically make the certificate no longer valid. So there are some advantages to using a outside certificate authority. Largely, that setting one of those up is an entire discussion unto itself, so I'm not going to cover it other than it is possible to do. The last piece is the -dn. This is a unique name for the server. And it's given in LDAP format. There's a whole bunch of different options you can give. Between the CN, which is the common name, O, which is the organization, OU, organizational unit. There's a number of other different levels you can give. The only one that is required is CN. And what you have to do is give it a unique name. Outside of the label, which that doesn't necessarily need to be unique. It needs to be unique per server connection. The CN is truly unique. So it tells it when it's validating the server, this is the server, this is how it's known, this is what it is. For our purposes, if you're dealing with a small company, this probably doesn't matter. If you're dealing with a large enterprise, and especially if you're dealing with a third-party CA, this may matter a lot. So you can just need to make sure you're giving it for each server or each different private key pair a very unique name for it, and get very, very specific with a really long string with different elements attached to it for how you want to name it. In our case, we're just giving it the Informix server name, entirely dependent on your environment for if you're really going to care about this, and if so, how much do you care? So once we've run this command, what we have done is we've already created our key stash, our key database. This is then going to create the certificate, so the public-private key pair for it, and store it in there. And then it's going to take the password that it knows from that key database and store it into the stash file. Server.sth, which is our stash, and ifix server KDB, which is our keystore database. Please make sure these are Informix 600. These are very sensitive files, and you do not want to have this. There's no reason for anyone that is not Informix on the server to have access to these files, and opening it up at all, basically greatly weakens your ability to have a secure system. Because if, someone with bad intentions has access to your private key, there's a lot of things they can do. So at this point, our database, our engine is ready to go. We can bring up the listener right now if we want to, just by starting the system. So we want to though connect local clients. So we're going to do that first. Set up. So this is so our local utilities, our DB accesses, our on-stack commands, etc. And if we have ESQLC programs on the physical box that the Informix system is, we're going to get those set up. The same process I'm about to do here will also work for any other Unix systems that you may want to have access a SSL-based Informix system. This will be the same process. So the first thing we're going to do is create another Keystore database. So this is going to be our client one. Notice the command is virtually the same. It's going to do keydb create db. This time we're going to call it CLI keydb. The name is entirely what you want it to be. This one does not matter in terms of how you want to name it. We're going to have a password, we're going to tell it CMS, and we're going to tell it to stash. The second thing is we've got to then to get the private key, the public key from the server key store. So that is the next thing we're going to do. And we're going to write it out to a file called ifxserver.cert. This is going to be a plain text ASCII file. It's kind of ugly, but it's plain text. You can open up in VI if you like. So we're going to run it with a cert, and it's going to use the extract flag. We're going to tell it to use the IFX server database because, again, we're pulling this from the public-private key pair for the server itself. We're going to tell it the format is ASCII. We're going to tell it which label. So this will tell it, we're going to tell it the file to pull from, so it's the database to pull from, and then the label will tell it which record to pull from. We're going to give it the password, and then we're going to give it a target, which is the actual flat file in the system. Once we have that cert file created, we only need that once. That file then can be copied around to any of our clients that we want to actually give access to the system. So now we have the cert. Now we need to add it to the client key store. So we do cert add db stashed. We tell it which label to use here. Again, the label will be used to match it. And then rather than telling it any of the information about the server, we're going to tell it to use the file, the ifxserver.cert that we pulled in the last step. So it's going to take that cert file, add it to the client key store database, and have it attached to the IFX encrypt label. So when we actually are pulling an application trying to connect, it'll know if it's looking for the IFX encrypt label, this is the public key it's going to be using. So last step we need to do is create a new file that is not there by default. It is in the Informix dir/etc directory, and it's called conssl.cfg. Needs to be readable by any users that are going to access these as a client access SSL, and it needs 2 lines and only 2 lines. SSL keystore file, SSL keystore STH, which is our stash, and we just point them to whatever files we created in the prior step. So the keystore, the client keystore, and the client stash file. This file is what is read by client SDK utilities or anything accessing it. It's how it knows where to go to pull the connection information and all of the key information. So this file is really important. But you only have to mess with this once. So final steps. First thing we do is bring the engine up or bring the SSL listener by itself up if the engine was already up. And now, as soon as we've done that step, we are now running encrypted. I'd recommend, especially the first few times you do this, you bring the engine offline to implement this because you want the engine, and it will break, I will tell you, especially when I was getting this class together, I did it a number of times. It will stop bringing the engine online and throw back a semi-useful error message if for something is wrong with the certificates or with the key store or with anything else with how you've configured the system. It'll come back, toss you a hopefully useful error message that you then can go fix. Common one I ran into was if I had accidentally not named the key store file the same as the DB server name, for example. It'll prevent the engine from coming up, you fix it, and then it comes up fine. So I recommend do at least the first 2 times doing it with, in a maintenance window just till you get the feel of it. So at this point, after step one, our engine's online, we're running encrypted with an encrypted listener to be specific. Second thing is we want to make sure that our existing TCP ports work. I just always go to DB access, go to connect and make sure those work. And then lastly, use DB access to connect to SSL. That way we verify that the SSL listener's up, it works, and we're able to work with clients on it. And again, you can do this exact same process of create the key store and then import that cert for any other Unix systems you've got running that you need to access this. The only other thing is obviously add the onsoc SSL listener line to their SQL hosts. So Windows. So this is the slightly trickier bit, but one of the parts I really wanted to highlight because oftentimes when we're running Unix applications against an Informix database, they're running on the same system, or maybe it's a server that's physically sitting next to the Informix box. There's usually not a lot in the way that, is a big security hole or a place that somebody could actually gain access to. Our Windows clients are a different thing. Maybe you have a fat application that runs on the Windows system itself that connects over ODBC. Maybe you've got your Windows server in a different data center that's got an application pointing to. Maybe you have clients that are using some third-party tool to directly access your data. A lot of different ways that Windows clients seem to hit, and Windows is more likely to be potentially vulnerable. And also, it's just more hops in between that are more places that somebody could be sniffing data. So really wanted to highlight setting up Windows. I'm assuming for this example, and all of this, by the way, I'm going to do a live demo at the end. But I'm assuming that you've already installed the client SDK on Windows. So by default, it goes in C, program files, IBM Informix Client SDK, something to that effect. If you're running an older version, there's a few different directories they put it in the past, just adjust accordingly. The first thing you want to do is decide where am I going to put our key store and our stash files. These are a few tiny files. You can put it. Some people just do like they do on Unix, create an SSL directory or use the SSL directory under our Informix Client SDK directory. Other times, and this is fairly an easy way for me personally, is I'll use like cont/SSL. Again, entirely depends on your environment. It really doesn't matter. But we need to decide where we're going to be working with. For example, here we're going to be using CSSL just because it's less to type out and means I don't have to write a real long path repeatedly in these slides. So just like on our Unix side, we need to create a conssl config file. This needs to be in our client SDK directory /etc. If you're running more than one version of client SDK, some people do that, or they may have a 32 and a 64-bit version. You need to have a copy of this file on each of the ones you're going to run. It needs to contain, just like on the Unix side, SSL keystore file and SSL keystore STH. One note that I ran into here. If you remember the old DOS formatting for directories with spaces where it does a little tilde and then 1 or tilde 2, you have to do the same thing here. This file has a problem with spaces in the directory name, so if you put your SSL files into a directory that has a space in the name, you're going to have to get the DOS name to put it on that string. I just wanted to put that out just as a little gotcha. So generating our keydb in Windows. First thing is we're going to get our cert file, the same one we pulled in our earlier steps when setting up the Unix client. Same cert file, we just pull it over onto our Windows box. For example here, I'm going to just put it into our c:/SSL directory. The second thing is running a command window as administrator. If you've been running Windows forever, you probably know this already. If you're not a real Windows person, but you may have to manage them, the trick way to do it is you open your start menu, type in command. This will work in Windows 7 and Windows 10. If you're running something older than that, just Google it. And then right-click on the command prompt option and choose Run as Administrator. The reason for this is some of the commands we may need to be run on the administrator level, so it's better just to be running the command window as the administrator access level. So next thing is add your GSK8 bin directory to your path. I did a fresh install of this on Windows 10 a couple of days ago. It automatically added this to my path. I didn't have to do a thing. When I've worked with some of the older client SDKs, I did have to manually add it. So if you need to do it manually, set path equals, and it's just a little different. This is the Windows world. So you do percent path percent. That's how you do the environment variables, and then semicolon, and then the path to the GSKit. The reason we're doing that is this is just a one-time thing. It's just so we can run our GSK8, basically know where it's going to be pathwise. So now that point, we change directory to the SSL directory, and then we run the GSK8 caps IC md underscore 64.exe. It's Windows, so everything's .exe for this. The commands are very similar, or the same. It's keydb, create db, and then the client keydb.kdb. Give it a password. We tell it to type CMS and stash, and then we're going to do the same thing we did on the other one, where we do cert add to the client db database, label ifx encrypt, file ifx server.cert, stash, format ASCII. So we're taking our cert file we pulled from our Unix box. We've created our client keystore, and now we're adding that certificate to our client keystore. So then you set up your ODBC connection as you normally would. And then rather than using onsock TCP, use onsock SSL, and then make sure to use your new listener that you created, and then test it. So a couple of notes here. You can have a client for the client keyring, which is the keystore. The terms get used interchangeably at times. You can have multiple certificates. So you could have 10 different servers. Import each of their certificates into there, as long as each one has its own label. And that way, it's already set up, so you can go in and connect to any of those over SSL. You can also take your same keyring that you created here, the keystore files you created here, everything in C:\/ SSL in our example, and you can just copy that to another server. As long as the conssl and your keystore files match up, you'll be fine to actually deploy it that way. So you don't have to necessarily manually run all of the GSK commands on each Windows system. If you've got a deployment tool, you could generate a client store with all of the files you need and just deploy it out. The other big one is just make sure that any clients, if you're running with multiple people on the system, this goes both Unix and Windows, any client, if you have different users that access the system, that those stash file and the keystore files are readable by that user. They don't have to be able to write to it, they just need to be able to read from it. So a couple of alternatives so at this point, by the way, we now have SSL, we've got it all connected, and I'm going to go demo all of this in a moment. But I wanted to bring up a couple of alternative options because there may be cases where you need them. Informix does have its own built-in encryption method. This is an older method. I have not worked with it personally, but it's called Informix CSM. It doesn't support quite as much as the Informix that an SSL does with GSKit, but it is out there. If you've got some legacy pieces, there might be reasons why you need it. It's fairly complex to set up. Again, I haven't worked with it. I haven't benchmarked it, so do your own research on it. SSL is definitely the direction Informix is going. So that really is where I would recommend you put your energy if you're doing something on at least a relatively new system. Another way that a lot of customers deal with it is using a permanent or an on-demand VPN, where basically anytime data is flowing from point A to point B, there's a VPN connection. If you do that, it means everything in transit is going to be encrypted. If you're dealing with something where you're dealing with older hardware, and you can have a software-based VPN or you can have a hardware one. They both work, just depends on your environment. But if you set it up so that you have, if you have an older system or a slower system, that way you can offload all the processing required to these hardware devices that are specifically meant to doing a VPN. So in that case, also all the encryption, everything else, you can hand over to your security team, tell them to deal with it, not your problem. So that's the pluses. The negative on it is from when the data leaves the server until it gets to that VPN point, and then same with on the other end from when it, the VPN point ends to the client application, the data will be unencrypted, so, or not encrypted at all, I should say. It's all in clear text during those jumps. So if there's not much in between the server and the firewall, that's probably not a problem. But just that little bit of clear text may be enough to flag auditors, or it may be a few jumps. Your VPN may be on the edge of your network, in which case anywhere in your network would be seeing the clear text. It all depends on your environment. Another way is using an SSH tunnel. You can actually set up SSH to act as a secure tunnel between two different servers. And you can actually then put tunnel traffic through it. I've done this for clients. It actually works pretty well, where then you use SSH to get your encryption. And because you're basically dealing with the VPN ends both being, or the encrypted ends both being on the servers that they're going to, it lets you actually have a encrypted tunnel between the two without having to set up Informix encryption. This can be a decent solution if you're dealing with legacy applications that don't support SSL, for example. This can be a way around that. There's something called SPWDCSM for Informix, a simple password communication support module. This will let you set up a level of encryption only for your connection, or for your actual connection attempt. So it'll encrypt your login name and your password, but then once you're actually established, it's no longer going to encrypt the data. So at least would give you that level of protection. There's also, you can have a mixed environment. I've talked about this for rollouts, but there's also logistical reasons why you might have a mixed environment where some of your data is encrypted and some isn't, where you have your TCP listener and your SSL listener, and you have certain processes that go encrypted, certain processes that don't. Maybe your nightly batch jobs that are coming from the server right next to your Informix server, you're processing, tens of gigs of data every night. Maybe you don't want to have to process all of that encrypted, but everything coming from your Windows team, you want to make sure is encrypted end to end. All depending on how you want to do it, Informix will support it. And again, if you want to use a central certificate authority, you can look at doing that. Again, outside of this talk, but I definitely know that is a requirement at some environments. So if that is one of yours, you can look at how to tie in your GSKit into a central authority, or certificate authority. Sorry. So before we go to questions, we're going to go into demo. What I've got here is two servers. First one I'm gonna bring up is our Linux system. So this is a 12.1 FC11. Not much up my sleeve on this one. Right now it is only running two listeners, our shared memory and our TCP. I haven't set up anything yet. So I'm gonna go through the process quickly here. I don't want to go through everything, so I'm gonna speed around a little bit here. So the first thing I did update the onconfig ahead of time. So I have done the Martha Stewart thing of here's the pre-made and here's the final product. And what I do have is the two files, and you can see the difference on the second line on each one. So I've added the IFX_server_SSL to our DB server aliases, added the net type sock SSL, added the VP class encrypt, and changed keystore label, which is there by default as blank, and change it to IFX encrypt. So I'm going to go ahead and bring our engine offline. I always double check, just even on demo time, making sure I'm on the right server. Never want to bring down the wrong one when flipping between windows. And so this is a little VM image, so it may take a moment to come down. And so I'm going to copy the SSL version over top. So if I view our onconfig file now, we'll see the SSL keystore label. There's a number of different things you can tune with it. I'm keeping this fairly simple. So our onconfig setup, that's the one I just didn't want to jump through a lot of hoops. Next thing is our SQL host. So we need to have an IFX server SSL. And as discussed, rather than using onsock TCP, we're using onsock SSL. I called the server itself Informix server. I know that is incredibly unique. And I'm going to give it port 9089. Again, if you haven't done a lot of this, every listener for Informix that listens on a network port, so TCP, SSL, etc., needs to have its own unique port number. So we're going to go 9089 for SSL. So at this point, Informix has been set up. The next thing we need to do is actually set up our encryption. So the Informix SSL directory is already there. GSKit is already in my directory. So we see the file is there. So and for this on this version of Informix, it installs it into the bin directory. So first thing we do is create our server key store. Note that again, I'm calling it ifxserver.kdb, which is ifx server is our DB server name. Giving an incredibly secure password there. And what it has done is it's created several files that are used. The main one is our keystore, the KDB file, and our stash. So the next thing we need to do is actually create our certificate for our server. So again, I'm using -stashed here, so it knows to use the stashed file to pull the password. Gonna give it the size of 2K. You only need to use this is going to be the default certificate for the server. And again, we're telling it the common name is IFX server SSL. This can be whatever you want it to be. Again, it doesn't tie to anything. It just is useful for tracing it. And if you're dealing with a real complex environment, you do need to make sure it is unique. So at this point, we technically are done. At this point, Informix is set up for SSL. But before I bring it online, I want to create the client side of this. As I said, this is really 5 commands. It doesn't take that long once you have it all planned out. So again, we're calling this one client keydb. Telling it type CMS, stashing it. So the next step we're doing, this is where we extract the certificate. And remember, we're telling it to use the Informix server database for this process because we need to actually go read the public key out of the server database before we can then bring it into the client database. So we're telling the output to be in the format of ASCII. We're going to use the IFX encrypt label. So that tells, again, we're looking at the server database. We're looking for that label when we're pulling the data. So what we have now is the IFX server.cert. You can look at this. You may, if you've ever worked with SSL certs before, this should look familiar. It's our unique certificate here with, this is our public key. That is what we need to deploy to any client. And what we're going to do is deploy to this local client right now. So we're going to tell it to add the certificate to the client database. We're going to use the stash password. We're going to tell it to use the label IFX encrypt. And I just realized I do have a typo. Extra dash there I don't need. We're going to tell it to use that certificate file we just generated. And we're going to tell it the format is ASCII. Okay, great. So now our client database, we notice the size has increased, has the public information. Our server has the information for the public and private keys. We should be able to bring the engine online now. And moment of truth on live demo. I always do verbose every time I do do a change like this, just to make sure there's nothing unexpected in the logs. So you notice here that there is forking one SOC SSL listener. So we have a GNTT. We can actually see that the SOC SSL is on 9089. And so let's test it. Let's make sure it works. First thing, we're going to connect to our TCP listener, make sure everything is still good there. Last thing we want to do is have broken, something that is preventing clients from, connecting normally. Bam, we're in. All I've got in the system is stores demo, nothing special. So our next thing is going to clear everything out, connect, and we're going to connect to the SSL. So this is where something has gone wrong, which is always fun during a live demo. But it's given us a error message that we can work with. So the keyring open error. I will tell you, I actually ran through these exact steps before we got on here, and everything worked fine. So I'm going to double check my syntax here. So the first thing we're going to do is, so the nice thing is, though, the server side works. Server side we know is up and running. I'm going to get, I do want to validate here that our IFX server files are all 660 or 600, which is exactly what they should be. Our client database can actually be a more wide open, since we want anybody accessing it as a client to have access to that file. So we've created the database for client. I apologize. I'm going to look at my commands here to see what I typoed wrong here. Okay, that all looks correct. So we extracted correctly, and make sure adding correctly. Stashed label IFX encrypt file. That all looks correct. I will be honest, one little typo here and there will actually cause problems. Let's try it with password. Okay, so running live demo, something went wrong. I'm gonna try recreating it just very quickly. By the way, if you need to delete the client database, that's it. You don't have to do anything special there. Everything is self-contained. So we're going to create it anew. We've already extracted. So all I have to do is add again. Pretty much what the keyring open error means is that it's actually having problems accessing it, and I just realized what I did wrong. So I mentioned several times there, and I didn't even follow my own notes on this. conssl.cfg. So that's the error message you'll see if you're missing conssl.cfg. I did create the file in advance, did a little baking ahead of time. So the SSL keystore file, SSL keystore STH or stash file. So it's now created in our opt-informix etc directory. DB access, connecting. And see, it takes a moment longer because it does have to enable set up those pieces for encryption in advance. But now we have access to our data, and now our data is going across encrypted. So I'm going to very briefly show the same process on Windows, and then we'll jump to questions. So this is a Windows 10 system, totally clear from earlier today. Decided to disconnect me there. So there's another one. It's got the latest client SDK for version 12. It's installed 64-bit. We have our SSL directory created. This is, again, this directory is entirely from my own decision that I just decided to put it in :/SSL because it's convenient for a test. And what I've done is I've created the conssl file in advance. So notice we have :/SSL client keydb for our stash file in our keystore. We don't have those files created yet, but we have the file. And why I'm copying it this way is just because Windows doesn't like you actually editing files inside of a protected directory, which the client SDK is. So I always create it outside and then copy it in so I can go through the administrative jumps. So we now have our conssl file in our client SDK directory. Note again, :/program files Informix Client SDK. Your mileage may vary depending on the system. So I'm going to open up an administrative Windows command prompt. So right-click, run as administrator. And we're going to go into the SSL directory. So there's nothing there right now. So what I've got here is just an SFTP connection over to the server between the two. So, and I'm going to pull the certificate file over into the SSL directory. So it's pulling it directly from the Unix box over into the on the Windows system. We can see the file is there now. So all we have to do in this case is verify that our GSKit, GSK8 applications there. We're going to create the client database. Same commands we used before. And then we're going to add our certificate we created. Note, we're still using the label IFX encrypt because we want to make sure it knows what server it is. Telling it to stash, so it's using the password. All right, we see we have all of our client keystore files, the KDB and the stash file. Now let's test it. So I did create the TCP connection earlier on to make sure everything worked. So it was already created, and I can go through. I created the Bob user, the one we saw their password for earlier. So test connection successful. That's our OnSOC SSL, and we can also verify the OnSOC TCP. Oops, the wrong port number. So we now have SSL, and just to prove there's nothing up my sleeve, if I move one of these files, let's say I am going to rename the stash file to clientdb2 and the keystore file to clientdb2, so they're no longer where they were. If I try to change this back to the OnSOC SSL and apply test connection, I think it has it cached. So GSK error, bad key file password, because it can't read the key file password. So if I change it back, I can now connect. So I'm now able to do whatever I was doing on Windows over SSL. I don't have to change my applications. I don't have to change anything else other than just my ODBC connection. Um, and I can take these two files. I don't need any other ones, but the SDH file and the KDB file, and obviously the conssl.config file we talked about. But take those, deploy them out to any other clients who I want. They can connect through SSL as well. And each one will have its own unique key every time it connects. So the system works. It works really well. There's just a number of little things to consider, but I spent probably 15 minutes on that demo, and 4 minutes of that was because I forgot the conssl file. And we're up and running with encryption on a system from absolute stock Informix. We've worked with it a million times to now we're running with encryption. We've now made the auditors happy. We've made our, chief security officer happy, and we can go on with, the rest of our work. So questions. I'm going to open this up. If you have not done so already, I'm pulling up chat. Feel free to toss in the chat if there are any questions. Well, folks are thinking if there's any questions, I'm just going to hop through. We have a couple of webcasts coming up. This is brand new, just announced breaking news. So Lester is going to be doing next talk April 30th on upgrading and basically information about version 14 and upgrading and basically working with version 14, upgrading to it, information about it, and using Informix HQ. This should be a really good talk. Especially if you're on an older version, I would start looking at 14 now, start evaluating it, because obviously that is the future of Informix. And then Mike Walker is doing a two-part talk. First one is May 2nd, the second on June 6th, about doing migration and export. Should be some really good information if you're looking for doing any kind of migration work or trying to speed up, tune, improve your export process with Informix. We have a few training classes came up. We just had a great advanced Informix performance tuning last month, and then we've got April 22nd. We've got our Informix for database administrators. If you've got anybody in your class or in your environment that you think needs to get into Informix administration, this is a great class for them. I know it's only a couple of weeks away. We are going to be covering that in the September course. We are going to be covering Informix 14, so brand new material there. As always, it's on the website if you have any questions, or feel free to contact us. We have, you may have seen this before if you've seen our webcast, but recently we've got new training servers for our classes. If you worked with our old ones, they were a little on the slower side. These new ones are brand new workstations that every single student will have their own. So when we're doing testing, you're not having to deal with a little dinky virtual system or trying to share a system. No, everybody gets their own server that they're going to be working with. Each one with 8 CPUs, 16 gigs of RAM. We play around with solid state as well as traditional disks. So you really get a fairly good server to play with when we're actually doing this. Get a good handle on it. Obviously, we have our remote DVA support monitoring. We do 24/7 support. We give folks just a set of experts available to them. Other environments will do, full support. Just depends on, we'll tune it to whatever level you want. We do performance tuning, training, consulting, development. If it's Informix, we do it. And thank you very much for being on. I don't have any questions right now. I know Lester was on. Is there anything you want to add, Lester? He may not have his headset on, though. So, well, thank you all very much for being on. Feel free to email. Feel free to email me if you have any follow-up questions or comments. Again, if you're watching this live and want to send it around, give it a couple of days. We'll get it processed and get up on YouTube and on the website. Thank you all very much, and look forward to Lester's talk at the end of the month. Thank you.